Here we're going to be talking about parallel and perpendicular lines. We're still going to be using the equation y equals mx plus b, which is our slope-intercept form of the equation, because we have a slope and we have a y-intercept, and that relates our x to our y. Our coordinates are related by that slope and the y-intercept. Now we're going to be talking about two different forms of that line where we have parallel and perpendicular lines. The only thing that's really concerned here by parallel and perpendicular lines is the slope. That's the only thing that really changes. When I talk about parallel lines, I'm talking about lines that have the same slope and they never intersect. They never actually run into each other. They never touch each other. The distance between the two lines is always the same. You can imagine train tracks for this. That's the easiest real-world example that I have. They run together, they never come together, they never touch, and it's always the same distance between them because the train has to stay on the tracks. The slope in the equation is the same. So that 2 and that 2 represent the slope. That's the same number. And on the graph, you can see that that's also the same. You can say they run together, but you really want to actually find the slope. Let's count our rise and run going from that point to that point. Up 1, 2, over 1. That's a rise of 2 and a run of 1. That's our slope. Top one. Bottom one is going from there to there. It's still going up 1, 2, and over 1. 2 over 1 is the slope for both of those lines. Parallel lines have the same exact slope. They're never going to touch. They're going to have different y-intercepts. You can see that there and there. They have different y-intercepts. That's represented with this 3 and that 1. Perpendicular lines are different. They meet at a right angle. That's what you can see there. And they have opposite and reciprocal slopes. They intersect at one point and they share a 90-degree angle. I think about two roads that are crossing each other. Usually when you see a four-way stop, you'll see two roads cross at perpendicular lines. They share a 90-degree angle. That's what this little box is indicating. They have opposite reciprocal slopes. When I say opposite, I mean positive versus negative. And when I say reciprocal, I mean the fraction flips upside down. So I'm going from A over B to B over A. It's got to have both of those two parts. You can see that in the slope here. Negative 3 over 2 changes to a positive 2 over 3. The fraction flipped upside down. It was a 3 over 2. Now it's 2 over 3. And we lost that negative sign. We have the opposite form of that number. It went from a negative to a positive. I'm going to count it out on the graph just to show you. You don't want to just estimate. You don't want to just look at it and guess, yeah, I think they have a right angle there. You want to actually count out the slope. So for this negative slope, I'm going to use this point, y-intercept, and I'll use that point, that's actually the x-intercept. And I'm just going to count out my slope. It's going down 1, 2, 3. That's negative 3 as my slope. Sorry, negative 3 is my rise, and then 1, 2 is my run. For the second line, the positive slope, I'm going to use that one and this one. This is going up 1, 2 spaces, and then over 1, 2, 3. Up 2, over 3. The fractions flipped upside down, and it lost its negative sign. When I'm given the equation, there's only one part that's important. I don't care about the y-intercept, I only care about the slope. So I'm trying to figure out, given that equation, what's the parallel slope and what's the perpendicular slope. So the parallel slope is just whatever slope I see. The slope is not going to change. That is my slope, 1/2. A line that's parallel to it is going to have the exact same slope. Actually, let's just do all the parallel slopes in the beginning. Parallel slope to this, I'm just recognizing the slope there, that's 4. The slope on this one, it's not the number in front. This is the y-intercept. That 2 is the y-intercept. The number that's being multiplied times the x, that's my slope. It's a negative 1/3. The slope is represented by the number that's multiplied. It's attached to the x, the number that's attached to the x. The same kind of thing on this next one, x over 4. There's no number that's really being multiplied times the x, but we can rewrite that as 1/4 times x minus 4. Again, we don't really care about the y-intercept at all. We're just looking at the number that's affecting the x. It's being divided by 4 or multiplied by 1/4. The slope there is 1 over 4. All right, the next one says y equals 5. So my y value is always 5. If I think about a table there, y is 5. Doesn't matter what x is. X can be 1, x can be 2, 3. Y is always 5. That's what that graph looks like. That's one of our special cases. Y equals 5. So that is a horizontal line, and horizontal lines don't have a rise. There is no rise to this. It doesn't go up or down. So it's just a slope of 0. X equals negative 2. I'm going to graph that on that same picture. X equals negative 2. That's the opposite. That has a slope that goes straight up and down, which we actually can't define. That's an undefined slope. All right, so the next one, it's not as clear. It's not given to us in slope-intercept form, so we have to find slope-intercept form of that line. We have to make this look like this, y equals mx plus b, so that we can easily see our slope. So I basically just want to solve for y. I want to get y completely by itself. This is supposed to be a y. Sorry, I didn't notice that typo until just now. That's supposed to be a y. So I'm trying to get that y completely by itself. I need to get rid of everything that's attached to it, and I'm working backwards to it. I have to cancel out that negative 4x as my first step. So I'm going to cancel out a negative 4x by adding 4x to both sides. Remember, these don't get combined. Those aren't like terms. I just rewrite it. So that gives me 2y equals 8 plus 4x. This canceled out, and I'm really just rewriting the expression on the right side. My last step, I got to get y completely by itself, so I have to divide by 2. I have to cancel out that multiplying by 2 by dividing. I'm going to divide it into both of these terms, 8 divided by 2 and 4 divided by 2. That gives me y equals 4 plus 2x. And now I can easily see my slope. My slope is the number that's attached to that x. It's just the 2. All right, now I want to look at perpendicular slopes to my parallel slopes. Once you have the parallel slope, it's pretty easy to find the perpendicular slope. All you really have to do is flip the fraction and change the sign. So going from this slope to a perpendicular slope, I'm going to flip that fraction, 2 over 1, and it was a positive, now it's going to become a negative. I definitely want you to simplify that. 2 over 1 is just 2, so this is really just a slope of negative 2. 4 is really the same thing as 4 over 1. So I'm going to flip that fraction. That becomes 1 over 4. And it was a positive number. Now it's a negative. You can put that negative out in front. You can put it on top. You could put it on the bottom. You're almost never going to see that, though. Usually you'll see it with the top so that it shows our clear rise and run. It's going down 1 and to the right 4. The next one, again, we're just going to flip the fraction. 3 over 1. And it had a negative sign. It's going to change sign, so it's going to become a positive. So I just lose the negative sign. And 3 over 1 is the same thing as just 3. Next one's really similar. I flip the fraction. 4 over 1. It was a positive. Now it becomes a negative. And negative 4 divided by 1 is just negative 4. I can't flip that fraction. I don't have 0 as a fraction. Actually, I guess you could think of it as a fraction. You could think of it as 0 over any number. Let's call it 10. If you flip that fraction, dividing by 0, you should remember what that slope is. Or you can think about it on this graph. Our original picture was this y equals 5. That's our original graph there. That's a horizontal line. A perpendicular line to that, actually I'm just going to use this one, the line that's perpendicular to that, is going straight up and down. That forms this 90-degree angle there, so it has an undefined slope. And the exact opposite is true for our undefined slope. When I'm thinking about a line that's perpendicular to that, I'm thinking about a line that goes straight across here, forming actually 4 90-degree angles. That's a slope of 0. The next one is a slope of 2. It's really the same thing as 2 over 1. I'm going to flip that fraction, make it 1 over 2, and I change the sign. That changes into a negative 1/2. Alright, so now we're actually going to have to use the fact that parallel lines have the same slope, perpendicular, have opposite reciprocal slopes to find a new equation. So on this first one it says, well, first off we want to find the equation in slope-intercept form. So it says a line is parallel to this line and it passes through the point 6, 5. That's an x and a y. So we have 3 pieces of information there. We have that it's parallel to that line. That's telling us the slope is 1/3. And then we have an x of 6 and a y that's 5. We're going to use this equation to figure out the y-intercept. To find the slope-intercept form of an equation, all we really need is a slope and an intercept. We already have the slope, so now we just need to find the y-intercept. I'm going to plug those numbers where they're supposed to go. M, x, and y. Go in for m, x, and y in the equation. I don't know b yet, so I'm going to leave that as a variable. That's what I have to solve for. I'm going to multiply 1/3 times 6, that's 2. 5 equals 2 plus b. And I want to solve for b there. I want to get b completely by itself, so I'm going to subtract 2 from both sides. That gives me that b is 5 minus 2 is 3. That's my y-intercept. That's my slope. And I just put them together into slope-intercept form. The x and the y are not specific numbers. They're variables. They're going to change, so I leave them as x and y. I put my slope and my y-intercept into the equation. That's the slope-intercept form. It's got slope and a y-intercept. Same kind of thing for the next one. It's talking about a line that is perpendicular to that same line, and it also passes through 6, 5. So it's perpendicular to this slope, perpendicular to this line. My m is going to be the opposite reciprocal of that slope. It's 3 over 1. That's flipping the fraction, and then I change the sign into a negative. That's really just the slope of negative 3. And I still have my x and my y. That's 6 and 5. Setting it up the exact same way. Y is 5. Negative 3 is my slope. 6 is my x, and I still don't know my new b. I have to find that. Same first step. I'm still going to multiply negative 3 times 6. Gives me negative 18. And I have to get b completely by itself, so I have to cancel out that negative 18. I'm going to add 18 both sides. That gives me 23 is b. I have my y-intercept. I have my slope. I'm just going to put those two together into the slope-intercept form of the equation. That's it. You could test this just to make sure that you're doing this correctly. You could graph both those in your calculator easy enough. You could type that into y equals, type that into y equals, and make sure that the slopes actually look like they're hitting a 90-degree angle. The next one says a line that is parallel to 2x plus y and equals 9. It's that equation, and it's parallel to that. So we have a problem there. We don't see the slope right away from that. We have to find the slope from that. We know that it's parallel to that, so once we find the slope of this new line, but we don't have that yet. We also know that it passes through the origin. Actually, we're going to deal with that in a second. Let's just deal with finding the slope first. We want to get it to look like this, y equals mx plus b. So I want to get everything on the other side of the equation from y. Means I have to cancel out this 2x. I'm going to subtract 2x from both sides. That gives me my equation. Y equals negative 2x plus 9. You could also write it the opposite order. It's the exact same thing. 9 minus 2x. Those are the same exact thing. Either way, my slope is negative 2. And it passes through the origin. That's telling you y-intercept. You could plug it back into this equation if you really want to. You can plug it into that equation with 0 and 0 in for x and for y, but we really don't need to. The origin is the y-intercept, so I can just write this out as y equals negative 2x plus 0, or even simpler, y equals negative 2x. On number 4, we have a line that is perpendicular to that, and it passes through this point. We have to do the same kind of thing as before. We have to find out what that looks like in slope-intercept form. So I'm going to solve for y here. I'm going to try to get y completely by itself. My first step is subtracting 4x from both sides. That gives me 3y equals, I'm going to put the x term in front just because I like seeing it in this form. Negative 4x minus 6. And we got one more step. We got to get y completely by itself, so I'm going to cancel out that 3. Multiplying by 3 is canceled out by dividing by 3. I'm going to divide that into both of these two terms. You could write that as a big fraction, but then it really doesn't make it clear what the slope is. My slope here is negative 4 over 3 times x. I can't simplify that, so that's my slope. This one I can simplify. That one I'm actually going to just do the division. Negative 6 divided by 3 is negative 2. All I did there was find the equation of that line. Now I can use that. I can use this slope to figure out this new equation. It's perpendicular to this line. This is our original slope, and our line is perpendicular to that. So our new slope is going to be the opposite reciprocal of that, which is 3 over 4. I switch the sign from a negative into a positive, and I flip the fraction. It also passes through this point, this x and y. So I'm going to use those three pieces of information, the x and y, and the slope, to figure out where this y-intercept is going to be. So I have negative 4 equals 3 over 4 times 3 plus b. Okay, so all I've done is plug in the m and the x and y. I found that m because I knew it was perpendicular to this line, perpendicular to that slope. First step, I'm going to clean this up a little bit. My first step is just multiplying 3/4 times 3. That's 9/4, or 2.25 if you want to write it as a decimal. Actually, I'm going to change it into a decimal as I subtract it over. I'm going to do minus that 2.25 on both sides. So I get that b is negative 6.25. If you want to write that as a fraction, you can. You don't have to. I'm going to put those both together in my slope-intercept form. My slope and my intercept. My slope is 3 over 4. My y-intercept is negative 6.25. Next one is a line that's parallel to the line in the graph and has a y-intercept of negative 2. So there's a bunch of different ways that you can start this. I'm going to start by just graphing this. My y-intercept is negative 2. I'm going to start out at that point. And I'm going to think about the slope of my original line, because I know if they're parallel, they just have the same slope. So I'm going to figure out my slope of this line. I see that that's starting there. And the next point that I can clearly see is that one. It's going down 1, 2, and over 1, 2, 3, 4, 5. So from that point, down 1, 2, over 1, 2, 3, 4, 5. That's my new line. And I pretty much have the equation already. I just said the slope, I just counted it out. -2 is my rise, -2. And over 5, ran 5 to the right, that's my run. So that's my slope, rise over run. -2, that's my y-intercept. Next one says a line that's perpendicular to that line, and it passes through the point 1, 1. So there's a bunch of different ways, again, that you could do this. You could use the equation y equals mx plus b, and plug in that as the x and y, and plug in our new slope, which is going to be 5 over 2. It's the same line as the previous question, so I see that's my original slope. I have a perpendicular line, so it's going to be the opposite reciprocal of that. I flip the fraction, change the sign. I flip it to 5 over 2, and change it to positive. You could plug it into this. I'd rather just look at it visually, so I'm actually going to plot this point, 1, 1. And then that says it's going up 5, 1, 2, 3, 4, 5, and over 2. That doesn't really help me find a y-intercept, so I'm going to count backwards. Down 5, 1, 2, 3, 4, 5, and over 1, 2. Actually, unfortunately, that didn't really help either. That is my line, but it's not really clear where the y-intercept is. I didn't actually hit the y-axis, so I do have to plug this in. So I'm going to plug in 1 for my y and for my x, and I'm going to solve for b now. 5 divided by 2 is really 2.5, so 2.5 times 1 is just 2.5. And then I have to subtract the 2.5 from both sides. That gives me that b is -1.5, which really makes sense. That is kind of clear there. You don't want to just estimate where it is, but it's at least confirmed by my picture. So my equation is y equals my slope, 5 over 2 times x, minus my 1.5, which is my y-intercept. Try those next 4 on your own. Go back to the video if you need to. Rewatch it. Go through everything that you need to try these 4 problems. At least try them. Please go back to the video if you need to.